Hi guys. So our topic of discussion today is how to build a backend app in Python, and hope you're interested in this topic. So my background is I'm a backend engineer myself. I'm working in a startup in Toronto, and um, I'm kind of new to Python. I was mostly using Node.js earlier, but I've seen there are few things which carry across languages. So language is never a barrier, but these patterns are very generalized, though when you use certain technology, you get to know about certain libraries, you get comfortable with them. That's the advantage. So if we, let's say, in this example, what we're discussing is if I'm using Python, then there are two choices of framework. Either people are using Flask or Django, right? And and then when sometimes it comes to database, then they have this is a very common ORM technology which people uses. It maps your database objects to your model in your app, and I will discuss about that right now. And then there are a few general practices which comes with TDD. You have to set up your some testing framework. This is a choice for a testing framework. It has its own terminologies which we'll be looking at a little bit today as well. And then um, so yeah, and then let's say if you're using a event queue or something, then there are integrations. Common integrations is your backend app might be communicating to other pieces of your architecture via HTTP. So then you have something called request library, right? And then let's say if it's a event queue, you can use like RabbitMQ. If you're on cloud, you can use uh, PubSub, etc. And when you deploy your app, so won't be talking about the app itself, the Flask thing. So yeah, this is like a backend HTTP framework. It gives you common functions. Like we'll just talk about how to build what is behind the Flask. So Flask can be one of the interfaces to reach out to this app can be called via command line, and that's how we'll be calling our app right today. Okay, so these are like common pieces of architecture. So I've a diagram here on my Meetup page. So at the end, that's what we have right now. Like if you keep on uh, developing individual pieces and follow best practices, this is what you end up with as an architecture. This is an open source book. I'll post the link in the chat right now, and also we can I'll post it on my Meetup page as well. Okay, yeah. So yeah, let's get started. um, what is basically, I'll ask you like these are like layered architecture on the back end, and what the recommendation is always to use like kind of some test driven development kind of environment. If you can do that, that would be best, because it can progressively give you feedback on what you're building. And then and you can really focus on, let's say, small pieces. Like let's say you're just integrating with some HTTP library. It can give you feedback, constant feedback. If you're just working with database, you can just focus on certain pieces, write tests for them, and that's how you can progress the development of backend app in a clean and modern way, basically. Yeah. So let me give you a breakdown of it. I actually got this app from somebody. Like they want me to build it as a whatever backend tester kind of. So this is the app. So what we want is we're building this order service. Order service is, just one endpoint, post endpoint with order service, which can take, user ID and product code as input. And then what we have to create is this order in our database. So our order will contain, user ID, product code, customer name, product name. And how do we get that? We can derive the customer name from user ID. We can derive the product name from product code, all these things. And, we should also publish the event for the same in our code, like to our event bus, like a pub sub event. So there's the schema which we can publish our order in, and that's it. That's the goal of the app. What's the challenge then? So one of the challenges is these are the HTTP service, product service. There are three kind of products as we see here. Each one just to simulate a test environment or something. We can say, like, when we request for family box, there is a latency, like it will be latent, like it will not return until it will sleep for 1 minute, kind of, to simulate the latency in the network environment. Then veggie box, it's it can return 500 status code. Yeah, so we have to handle around those requirements. Same for user, you can retry, and you can do 200 or 500 or something like that. So these are microservices, basically, somewhere hosted. You have user service, you have product service, and order service needs to interact with these external services to you know um yeah to fulfill the order for the client, right? To fulfill the order request. And that's what it looks like, basically. We're creating order, and to our order service, it gets some data from product and user service, and then it publish a event to our RabbitMQ. So that's our basic architecture. uh is my screen visible, like, totally? Like, font size is good? Okay. Yeah. Okay. Great. Thank you. So yeah. So how did I start the development of this app? So the theory is, like, you can start from database, or you can start from service, but whatever you start writing first, you should build tests for that. The approach I took is I started with my ORM. And there's an example of ORM, like SQL Alchemy, how we can use that. I'll be going a little faster, like it's not like step by step kind of a demo, but yeah, we'll be discussing all of these. So what we have is basically based on our, like, if your requirements are flushed out, that's always a good idea. Like, if you have few scenarios in mind, if you have overall design of your what you're trying to achieve, other than the business logic, like how it's integrating with rest of the environment, what else you want from your service. So that's always helps. So it always helps, we know, like, what we want to store in our order. So this is what we'll be storing in our order based on our requirement. So how do I so the question is, like, this is around just a schema. So in I was using helper functions like mapper to model my object, to model this object in my database. It will automatically get transferred. Then I starting a SQL session and all that. So yeah. So how do I, let's say, that's all I have to start with. I know what my order looks like, and I know where to get data from. So how should I just test the simple order? I should not worry about interacting with other services. I can always, create an order and start writing tests for that. So that becomes my test for model. If I so this is my model test class, and as you can see, I can create an order. I can create a user, which is mock user. I can uh, and I can get the product, and I can also get the um, um, my order uh, as well, right? So this is what my order object will look like, and I can go ahead and mark and test this. This test for ORM will be in here. So this is the first test I wrote for this service. It's directly integrating with my database. So let's discuss about one topic earlier. So what are different kinds of tests we have in TDD? So TDD, we have, unit tests, we have integration tests, and we have end-to-end tests. And there are different ways you can simulate all that. Integration tests, I would consider whenever your system is interacting with database, and if you are modeling, let's say if you input some row in database, will it be there or not? So that's your integration test. And then if you're requesting let's say some HTTP requests, what kind of behavior you are expecting that service to give you. So that's like your HTTP request. And then so the you have to it can so an end-to-end test is when you run your app, and then you can go and check in database. So you have to do a lot of work with end-to-end tests, in a sense that you have to start your whole app. Maybe you'll start some containers, maybe you do all kind of things, right? And for unit tests, it's always easy, like you're just testing the logic of a simple function. You can mock out the inputs, you can mock the output. Integration recommendation is, let's say if you're using a database, try to use a database, right? Or if you're calling HTTP, if you're, let's say you have a HTTP request class in your then you should try to mock out HTTP, or maybe call to real service. And you can simulate what are you doing if you're getting 200 or 500 or something. So it's not always clear. Like sometimes integration and unit can be like interchange each other. But so yeah, so let's talk about like how I tested this. So that's it. Like I just marked the what kind of orders I want to write in my database. I executed a insert. I already inserted. So this is the other way around. So what I did is I inserted orders in my database. I like I just took out some objects and ran like a raw SQL statement to insert those in my database. And then when I do I run this query, model dot order all, I expect that I get this back. And where this model is coded, I coded this model here. This is the model which we were testing. Okay. So that's one way to write a test for such a requirement. If you're it's I know it's other way around. Like we created model first, but we queried our database with using this model, and we checked like are we able to get the data back or not. So like I can just show you. So, and the framework I've set up for this is called PyTest. PyTest is, it's a library. It has a configuration file. So if you have used any testing framework, sometimes what you have to do is you have to run something before every test runs or after every test run. So this is, they call them fixtures, and it works in a dependency injection way. And what it does is, You can set up a in-memory SQL Lite database, which will connect with your SQL Alchemy model. Now, all my requests are going to this in-memory DB, and that's how I can, integrate the database, and that's how I can, get my session object as well. Like this was something else, but yeah. So these are the two functions which help me build like my in-memory database. And um, um, you know, um, yeah. So, uh, is there any question so far? I know it's too early, but like, is it what you're expecting? Eh, Okay. Yeah, all good. Yeah, great, man. Thank you. So yeah. So let's let's say if I'm running my test, what it does is it helps us with a lot of things. I'll just give you a brief overview, like, all files starting with test and all functions started by test becomes my, you know, uh, tests. And then, this session is coming from that configuration file I just showed you, conf test. And it just inputs this, the return statement, and then it inputs this session in my object. So it has to have the same name. And yeah, and then I can go ahead and execute the query with the model I built, and that's the great value we're getting out of this. So we just executed this query without executing this, like, and we were able to get the feedback on our model. And now we also have a sample object, and we can always refer to what order looks like in database, right? So why are we doing this? Like, so this is like a TDD approach to building, apps from ground up. So we started with the lowest layer. So all these architectures are like layered architecture, and if I have to model what it looks like is, it's your user sits here, like your app interface, and what user will generate is usually he'll send you a request, right, of some kind. So user send you a request, and then what we get, it will hit our app. It will hit our app, and our app knows how to react to this app. We call that, kind of, it will go to our handlers. And this is like a very common kind of an architecture. Then we say, let's say if I am doing a create order here, uh, so my request is, I got my handler, this evoked create order. Now this create order have to interact with all of my system, and it has to get user object, it has to get product, it has to, and then create order. And those, that's the job of my handler. And there can be complex business rules, etc., right? So somebody has to have this knowledge of how to handle the request, how to handle the business logic. And then finally, it gets stored in my database or a storage layer somewhere. And additionally, I can, and when it's done, I can also emit an event. Okay, so I just repeated what we discussed a little bit while ago. So I started at this layer, the lowest layer, like a database layer. And sorry. Okay, so we started at this lowest layer, database storage layer, and that's what we built with this model object. you can go raw object. You don't have to use any library if you like. Libraries just have some handler functions to create a session and all that. Okay, so I also built the same thing. Yeah, sorry for the noise, guys. Yeah, so sorry. So yeah, I'll be yeah, so that's the overview. Overview was more important because we are in a short session right now, right? And yeah, so why like can I use how I'm able to like so one of the important features which app should have is like extensibility a little bit. You don't always have to code for extensibility, you don't always have to go for extra layers, but finally you don't want to run you don't want to deal with this library like SQL Alchemy or anything. You want a simple interface, and that's what you want. So let's jump to what I want finally from my app. What I want from my app is exactly what I just told you. I want somebody to hand me over like, oh sorry, this is my order handler, create order, which we just discussed. I want somebody to just get me a user. I want somebody to get me a product, and I want to build that order and send it to my order object. So all of this can be possible if we build interfaces around it, around our libraries and function. We want a higher level user who is handling the request to not to be bothered with lower level details. And that's why what we do is we code for interfaces in Java. There's a term like always code for interface. So whenever you have some repeatable pattern, every object we should be able to fetch every object. It doesn't matter. So here I have the same interface for user and product object. Uh, uh, to get to get data. One is getting data from HTTP request, and one is getting data from let's say a SQL Alchemy database. But at this level, I'm not bothered where this object is stored. So that's the advantage of using let me show you. So what I did is I introduced the interface in my, because this is a very simple example, just one model. So of course, so my interface is simple. I want to add object, I want to get object, and I want to get all objects, kind of, you know. So that's what it looks like. If I'm going through a database, that's what my add, get, and list looks like. If I am going through HTTP request, I code in the same way. I just start a request session with that server, and add and list are not available, so they're not implemented. And get, but user is getting a same interface at handler level. So that's the pattern. Here we're calling it repository pattern. We try to generalize our interface with the at object level, basically, right? So now all my details which are related to SQL Alchemy or something, they're totally hidden. What I did in this object is, what I did is I created a model. So I created my data objects. This is my model. So now I just want to know what my product looks like. This is what my products look like. It's a data class. It's a concept in Python. I can make an immutable data class. So I just populate this field, and I move around this object. There is a concept in backend development, or in general in programming, value objects and kind of entity objects. Entity objects are something which so value objects are, they are pure data. So they are pure data. You just throw around that data in a database, and um, they don't have um, sorry, I'm missing on definitions, but I will definitely show you value object versus entity. And you know so one is yeah, so basically, two users, if they have same ID, they are equal. And but it cannot be said about data object. Data objects are, they have to be equal in every property, so they are just object references. And because let's say you have user 1 with ID 1 and user 2, but his address is changed, it does not mean that user has changed. So that's the concept of identity. But if you're talking about value objects are like pure data, the requests you received as an order or something like that. So you can always code your response schema or your schema. So it's a very good practice if you build around have some. So when I build order, I have to build order object, and then I can throw around this order object, and it will I have a chance to uh, so this is different than my SQL alchemy model. This is what, whenever I fetch order from somewhere, I will fill that order in this structure. So I pulled the schema of app in this structure. So this is my order object, this is my user object, and this is my product object. You know, uh, yeah. And so now I can just whenever I create a order or create an object, I just have to fill this model in. I'm getting data from my HTTP request for product, but I just fill this object and I return this object when I get this object. And so yeah, so that's important. Like we can go on little higher level or whatever. I added extra properties here as well. Just some computed properties which can be derived from. So my HTTP service just returns me these three things: code name and price. I just created some extra properties which I thought I may need as well. I can do that, right? Uh, I don't have to, I don't have a liberty to change any remote service. It's not under my control. This is what the response of the service looks like, but I needed a full name. Instead of copying or creating a utility function, I just added some extra behavior to my model object. I can fetch like a customer full name or something. Same way, I want to generate an event for the so I coded my event as well. So as we discussed, if is your requirements are good, what kind of event you want to publish. I wanted to publish this event. So what I did is I created an event model around this. And yeah. And then I went ahead and wrote some tests for my models. So I created this model object, and then I query my derived field, and I just asserted, does this field have the same ID, or does this field have the same date? And yeah, so those are some assertions. So those are also built into my test. So now my schema, if it changes, uh, my test will break. And that's how I can capture my model changes. If I break my model test for model, I know where what else can break. Like my test can guide me there, or they can guide me what was the previous schema, and let's say model object change their response, and now I have a way to track it or update it in my system at least. And I'll just keep on fixing my test, and I can refactor the new response from the product object, let's say. So same for so the event object. So I created an event. I want certain structure for my event. So what I did is I have a user object, I have a product object, I create order using user and product. There is no create order called here. I just hard coded everything. I created an order, and then I passed my create order object to create order event, and created an event, and then I tested on my event as well. Is my event is what I want it to be, basically, And yeah, does it make sense so far? Yes. So service layer is a different than repository layer. So service layer is where the handler lives. So these are kind of adapters. Adapters, I'm calling it like, there's a concept here which I listed in my event is port and adapters. Adapters are something, let's say, what we just discussed, uh, uh, this is a very common concept of port and adapters. Port and adapters are basically, I don't know the shape of my user object. I don't know the, shape of, like, inventory can be, some outside service. User can be live in database. So I just created a common adapter for these. So repository pattern is kind of, uh, my integration adapter to deal with database or something. So now I was able to, but this is still a single object. This is not a service object. Okay. So service object is which where my handler lives, kind of, which has some business logic in it. Now, this adapter to get an object. Now I'm making a HTTP request here, but I'm not even aware of that. I'm making a HTTP request here and I'm not even aware of that. So that's what my adapter looks like. Yeah. So just because it was a very small session, just to we're going towards end now. And so what we can do is also, like, as you know, there are abstract classes and implementations, right. uh, so where my app starts with, my app starts at this bootstrap step. I boot my app, I create my session, I create my message queue, I create my order, the adapters, right? And this is all my actual, I can replace any one of them if I like, I can replace product to a different service. Let's say if it's not a product service, it's some service on internet you were using for your payment gateway. Now you can just use the same interface, but you can integrate it behind the scene with different service, and you can call it product repo 2, right? And nobody can stop you doing that. But this order handler now don't have to worry about that, because I inject this bootstrap object into my order handler. And order handler, whatever you give, whatever you bootstrap your service with, so that basically makes your architecture more plug-in kind of an architecture. You can uh, integrate different thing without even worrying about, because we coded for the interface. And what my interface looks like, uh, all we need is, whenever you change that repository service, it should follow the same abstract repository pattern, because all my requests in my service object is is coded against this pattern, basically. So this is my, translation service, like repository pattern. But actual work is being done by SQL Alchemy for model objects. For request object, it's being done by, so I created this request object. It has, a retry mechanism built in, and all that. So how I'm doing that, I'm just, like, in Python, it's just like a library feature, kind of. So you have requests, you can, add a retry functionality into your session. So whenever my request is hitting HTTP or any HTTPS endpoint, it's being retried on these 500 400 messages. And so I get retry for free. I'm retrying 3 times here. And but what I did is I again inherited from my adapter class like interface, and I create a implementation for get, add, and list around that. And then my handlers can use these adapters, and I can change my adapters, but they just have to have these methods which we are expecting at the higher level, like get, all, put, those kind of methods. But yeah, but our apps will be dealing at this level, all the business logic will go here. So this is just the infrastructure code adapters kind of. And also it generated event here. So I generated event in one line. How I did that, I did the same thing for the event. I created the different kind of an adapter like publish. Now instead of rabbit mq, if you have some other queue, if it has a publish method, you can use it. And that's what I did in my tests here. uh, so what I did is I created a test for my, oh, sorry, I deleted those because I wasn't able to compile the code with this. So what I did is I created the my test for my handlers here, and I created a fake queue. So there is a concept in when you do test driven development, something called test double. Test double is yeah, sorry, I don't know what game, test double TDD. So test double is I just created a fake message queue. I created a message queue because I inherited from same adapter, and I uh created a publish event. I just created an array as my event bus and appended message to that. So then I created my fake queue. I gave it to my bootstrap object. Bootstrap object initiated with my handler, and that's how I pushed. So that's what makes my system configurable. So now I just started order handler with different kind of a event service, like a fake event service. And when I created a event, I just wanted to know if my order handler is working correctly and it's emitting an event. I don't know if event is not being generated correctly. That's the job of the event queue class, not the event order handler class. So that's how we can isolate behavior using test doubles in R. And yeah, and we were able to uh, create a write a test without using a real message queue. And yeah, okay, I think there are a lot of concepts here. I'll be sharing, uploading this video uh, on YouTube, like, and I'll post the link in the meeting no comments. And if you have any questions, let me know in comments, or I can, if you have some questions right now. We have 4 or 5 minutes. Do you guys have any questions? Like, any comments would be helpful. Yeah.
No questions. Just thanks a lot for the session. I'll read up a bit on layered architecture and I'll rewatch the video and try to get a deeper understanding. But thanks for the session again. You covered a lot of concepts and
Yeah, and and
yeah.
and and yeah, if you actually want to learn more about these concepts, I'll be posting a link to this. This is a open source book, and I find it like to be a great book. If you just start with, it covers everything from whatever we discussed today, and that's the source. Like, it's using
Okay.
building on a different
So,
example, but yeah. So it tell you about, it starts with what architecture looks like for modern apps, or like TDD approach. Yeah. So that's what we were trying to build. So these were the adapters, and our domain objects are the, our order services and all those objects, entity objects. And order handler is ours, it lives here. Order handlers, call repository, it populates domain objects, and then repository committed changes to database, and your requests flow starts from here. But yeah, you bootstrap your services, you wait for the request, you process your request, you just try to give your handler like helper functions using, get, put, all that. You don't have to handle HTTP requests in your handler, if you're calling out to extra services and all that. So yeah, so this is a great book. It goes step by step, and it has Cosmic Python has a yeah, it has a code base here. So it literally walks you everything from chapter by chapter. And like if you are into Python, yeah, it will you learn, pick up some concepts about Python here as well, what we were discussing at the beginning. um, you know um, like what the backend for Python looks like, these kind of concepts. Okay. Okay, great guys, thanks for joining this session. And I'll be sharing all the links, posting all the links in just one comment in my event page. Thank you.
Thank you so much, Nicole.
Thanks. Thanks again. Bye.
Thanks, Nicole.